All right, everybody, welcome back. Today what we're going to do is we are going to work on writing equations from the roots. So this entire time we've kind of gone the other way. We've taken the equations, the polynomial equations, we've factored or used the rational root theorem to break apart that polynomial into factors and then go from the factors to their solutions. Now we're going to go the other way. So it really is the exact same process but backwards. So for example, let's say that you are given x equals 3, -1, and 2. Well, what that means is we have x equals 3, x equals -1, and x equals 2. What we need to do is get their factors. So we need to go the other way. So we kind of need to think about it like we need to move everything onto the same side, which is the opposite of what we do when we are solving from factors to solutions. So I would need to subtract this 3 over. That gives me the factor x minus 3. And then I'm going to do the same thing with my other one. So I'm going to add this 1 over. It gives me x plus 1. And then I'm going to subtract the 2 back over. So it's on the same side as x. So we get x minus 2. So these are the factors. Now that we have the factors, all we have to do is multiply back out. So again, it's the opposite of what we did before. We would divide to get factors. So we multiply to expand. So I'm going to take my first 2 and I'm going to FOIL. We have first, outer, inner, last. That leaves us with x squared minus plus 1x minus 3x minus 3. And I still have that x minus 2 that I don't want to forget about. Now I can combine like terms. So those middle 2 are going to combine to a minus 2x. And I still, again, have that x minus 2. Well, now what I'm going to have to do is I'm going to have to distribute everything in my first polynomial into the next. We want to get rid of as many of these sets of parentheses as possible. So in order to do that, I'm going to multiply x squared by everything, and I get an x cubed minus 2x squared, and then I'm going to repeat the process with my negative 2x. So I get a negative 2x squared plus 4x, and now I'm going to do it with my negative 3 as well, to get a negative 3x plus 6. Lastly, I just need to combine these like terms. So my final answer is going to be an x cubed minus 4x squared plus a 1x plus 6. And this is the polynomial that has the roots we started with before. So it really is the same process, just backwards. Instead of factoring, we are going to first multiply out. So factoring is division. So doing the opposite. And then I am going to factor again, if possible, and go from the factors to my solution. So we're really just doing the exact same process backwards. Okay, so now let's look at a little bit of a different type of example. We have x equals 1 and the square root of 3. Well, one thing we need to keep in mind is every time we take the square root, we also need to include a plus and a minus. So I've got a positive root 3. I also need a negative root 3. And that is called its conjugate. It is the opposite part. So the process will remain the same as before. I am going to have an x minus 1. And that comes from x equals 1, where I subtract the 1 over. I am going to have an x minus the square root of 3, which again comes from x equals the square root of 3 that I've just subtracted over. And if I had an x equals negative root 3, I would add it back over. So I'm going to get an x plus the square root of 3. Now, again, the process is the same. I'm going to multiply out. However, what I'm going to do is I'm going to start with my back to binomials. And the reason I'm going to do this is they both have radicals. And so something interesting is going to happen when I do that multiplication. So I multiply out, I get x and x. So first of all, actually, I've got an x minus 1 still. But I'll have x times x, which is x squared. X times the root 3 is a positive root 3x. Negative root 3 times x. And then I'm going to have a negative root 3 times a positive root 3. Well, a negative times a positive is a negative. Root 3 and root 3 is root 9. Lastly, what I'm going to do is I'm going to simplify by combining like terms. And if you notice, what happens is in the middle here, these are going to cancel each other out. That always happens every time we have a conjugate pair and we are multiplying it back out. So I'm going to have an x minus 1 still, and then I'm going to have an x squared. Again, our middle terms will cancel each other, and I have minus the square root of 9 which is 3. Now our radicals cancel each other out, which is what I wanted, which is why I multiplied these two first. You could get the same thing if you multiply these, but you won't get all of your radicals to cancel until the end, which is this last step I'm about to do, which might make it a little bit more complicated. So lastly, I'm going to distribute in the x to get an x cubed minus 3x, and now I'll do the same thing with my -1. And that will be a minus x squared plus 3. So reorganizing this and getting into standard form is important. So I'll have an x cubed minus x squared minus 3x plus 3 is going to be the polynomial that has the solutions that we listed above. Okay? So we need to keep an eye out. Sometimes you are given all of the roots. Sometimes you're not. And so the important thing to keep in mind is square roots always come in pairs, positive and negative. So now what I'm going to do is do one last example. Maybe we'll do one more after that. But I've got x equals -4 and a -2i. Well, okay, let's think about where i's come from. I's come from taking the square root of a negative. Every time I square root, I need a positive and a negative. So I've got my negative, I need a positive 2i. So these are my solutions here. And now I can write my factors. X plus 4, x plus 2i, and an x minus 2i. Same process as before. We move everything over to the same side as x so we can get those factors. Now, just like before, these two are interesting. They're a little bit different because they've got i's, so I'm going to deal with them first. I'm going to multiply these two together. So I still have my x plus 4 in the beginning, but I'm going to do x and x, which is an x squared. X and a -2i is a -2i times x. A positive 2i times x. And then I'm going to have a positive 2i times a -2i. A positive and a negative is a negative. 2 and 2 is 4, and then I've got an I squared. So just like before, something interesting happens. Our middle terms are going to cancel each other out because, again, they are conjugates. They are opposites of each other. So technically, I've got an x plus 4, and then I have an x squared minus 4i squared. Well, let's keep in mind, we know what I squared is. I squared is really a -1. So I can replace this with a -1, and I then have x plus 4 times x squared plus 4. And now I can multiply out and get my final answer. So I'm going to have x and x squared is an x cubed, x and 4 is a 4x, x squared and 4 is a 4x squared, and then 4 and 4 is 16. So rewriting this in standard form, I get an x cubed plus 4x squared plus a 4x plus 16 is my final polynomial. Now, I do want to show one more, and I wasn't really sure I was going to, but we should be pretty comfortable with this because for the most part, it is just multiplication and knowing how roots work. Knowing where things like i's come from help this process. So let's do one more example. And what I'm going to do is I'm going to start us off with an x equals 1, and then let's say I've got a 1 plus I. Well, again, the idea is going to be the same. If I have a 1 plus I, i's come from square roots. So that means I should have a positive I and a negative I, so I'm really missing a 1 minus I. So this one's a little bit more challenging, but the idea is going to be the same. I've got x equals 1, x equals 1 plus I, and then x equals 1 minus I. Now, this first one is easy. We should have an x minus 1. What I'm going to do is I'm going to move over this entire group together. So it's going to give me a factor of x minus 1 plus I. So it looks a little bit weird, but we'll kind of get to that a little bit later on. And the same idea for the other one. I'm going to have an x minus. I'm going to subtract this whole thing over, and it'll be a 1 minus I this time. Just like before, I'm going to leave this one till later because it's a regular binomial, which, we're pretty comfortable with. And I'm going to focus on this part. In order to multiply these out, I need to regroup a little bit. So I'm going to have an x minus 1 in front, but I'm going to regroup and put my x and my 1 together. So I'll have x minus 1, and then I've got a negative I there. All right, well, over here, same thing. I'm going to group my x and my minus 1 together. And if I distribute that negative in, that minus I will turn to a plus I. And this is a little bit more comfortable for us. I'm going to FOIL out. So this time, this is my first term in each one. So when I FOIL, I've got my x minus 1 in front. And I'm going to multiply x minus 1 and x minus 1. That is my first. Then I'll have outer. And you know what? I'm going to need to give myself a little bit more room here. So first, my outer is now going to be a plus I times x minus 1. And then we'll do inner, which is a minus I times x minus 1. And then negative I times a positive I is a negative I squared. So just like before, our middle terms should cancel each other out. So that helps us. I've got my x plus 1 in front. And now I can actually simplify this. We should be pretty comfortable doing it. But first, outer, inner, last. And then at the end, I've got a minus I squared. Well, we know I squared is negative 1, so I'm going to go ahead and replace that, and now I can simplify. X plus 1 in front. This is going to become an x squared minus 2x plus 1, and then I'll have minus a negative, which is a positive, and those will add. Simplify one more time to get x plus 1 times an x squared minus 2x plus 2. And now I will distribute back out one more time. So x times x to the second is x to the third, minus an x times a negative 2x is a negative 2x squared, and then x times 2 is a positive 2x. I'm going to do the same thing with my 1. I'll have a positive 1x squared, a negative 2x, and then a positive 2. And now I just combine like terms and simplify. So I've got an x cubed in the beginning. Those are my 2x squares here. So I have minus 2x squared plus 1 leaves us with a minus 1x squared. I've got a plus 2x and a minus 2x, which will actually cancel each other out. And I have a plus 2 at the end. So this is our final polynomial. Again, I don't really need the 1 in front, but if you like to keep it, you are welcome to do so. So same idea here. This just requires a little bit more work because we are going to be regrouping on the inside here. And then I have a binomial that is part of each of those factors and going to need to be FOILed out. So it definitely is a little bit more work. These are definitely more of challenge problems, but again, the ideas should remain the same. For all of these problems, when you are doing them, you got to keep in mind that the process is the same. I go from solutions to factors and then I multiply out. Most students make mistakes in situations where you're simplifying radicals, for example, multiplying root 3 and root 3, or multiplying imaginary numbers. We forget that we'll have a negative 4i squared, and the I squared we could change to a negative 1, and it simplifies. I get that, I understand. The important part is keep the process the same and show all of your work. All right, make sure you're showing each step so you can keep track of all of your values as you are updating them, and that should kind of help you get to the correct answer at the end. Okay, thank you for listening, and if you have any questions, as always, please feel free to leave them in the comments. Have a good day.